which is written using standard will be run on Postgres, on Oracle, MySQL, but it's virtual. Actually, there is some disagreements. But we will talk about Postgres, so I will talk about Postgres. And this is a standard, some picture about some JSON. Actually, as you see, there is some root. There is information about, you see, the Moscow. This is about our building where our company actually is. I will use it for several examples. Again, I remind you that I am working as a research scientist in Moscow University, and also I am co-founder and CEO of Postgres professional company. So this is SQL JSON. I said already that we have JSON in application, and we have SQL JSON in database. So this is application environment, and it's specified by RFC 1759. And we have SQL environment where we have SQL JSON. So JSON is parsed, processed, serialized, and returned back. This is how simple schema how to work with JSON. So SQL JSON provides data model. So data model, what is JSON? Is a sequence of SQL JSON items, and each item can be recursively any of SQL JSON scalar, so non-null value of SQL types. SQL JSON null, SQL JSON arrays, SQL JSON objects. So you can see that this is what actually data model consists of. And also this standard provides description of JSON path language. JSON path language is a very powerful language to describe projection of JSON data, which can be used by SQL JSON functions. So when you, with the SQL JSON, you can more or less, you may describe which parts of JSON you want to use in very natural manner. So any programmers understand what's written. Before SQL JSON, before JSON path, it was very difficult to say that I want to use only this branch of the tree. And also SQL JSON contains the functions, how to build JSON object. So it's construction functions. Construction functions, the values of SQL types transform to JSON values. And query functions, so from JSON values to SQL types. And JSON path converts the SQL JSON types and converted to SQL types also. It's not actually easy to understand, better to show an example, yes, but this is a formal description of SQL JSON standard. What we have in Postgres, because this is a standard which is a formal description, but in Postgres we realize like this picture. So we have JSON in the application. In PostgreSQL environment we have JSONB. Instead of SQL JSON we have a JSONB. And JSONB is a subset of SQL JSON data model because it supports only ordered and unique keys. You know that we have, in Postgres we have two data types actually. We have, historically, we have textual JSON, which is very good for saving the original JSON, but very difficult to work with. And we have JSONB, which is binary JSON, but some people say that it is better JSON, yes, because it supports, it has a binary storage and supports very fast operation with JSON. But JSONB has keys are ordered and they are unique. So if you write key 5 and then key 6, then you will have just key 6 because its keys should be unique and they are ordered. ordered by their length and then by their names. And JSON path, we have it all committed to the PG12, this in June 2018. And I said that it describes the projection of JSON data. And we have the most complete and best implementation. So we have JSON path has 15 features described, and we support all of them. Other databases, they support only part, they have incomplete implementation. And we implemented JSON path as a binary data type. This is how we do in the Postgres. And we have SQL JSON functions just committed into the PG16. Maybe 4 weeks ago, it committed to PG16. So in September this year, you will have a chance to play. But you already can download some development version and work with it. The story with this commit is very strange because first time this SQL JSON function were committed to last year, to PG15. And we were waiting for this, but then community decided to revert this patch because of some problem. Now all this problem is solved and we have committed. So we have, in addition, we have very good indexes. Do you know that indexes are not part of SQL standard? So you can't find a description of indexes in SQL standard because SQL standard only about SQL, about declarative language to work with the data in database. And index is some additional structure to make your queries faster. It doesn't work, it has no relation to the language. So index, there is no standard, and every database, they have indexes and even syntax different. Yes. So our contribution, we implemented gene of classes for JSON-B, and which helps all these queries SQL JSON to work fast. Because this is very practical case. You can write a very good SQL query, but if it's slow, it doesn't work for you. So practically we need not the right syntax, we need the right syntax with a fast execution. So that's why indexes are very important. But do you know that indexes is not silver bullet? So it's not good like you create index and you expect that everything works much faster. Because indexes, they have an overhead. Overhead, it occupy more spaces, additional spaces. Indexes, you have to refresh. Yes? And sometimes indexes just doesn't help. Because if you, for example, create index on the sex kind of people, so male and female, this index will not help because approximately 50% of population are male and 60% female. So this index will be useless. So let me start with the JSON path language. Do you know what it is? How it looks? It looks like this expression. This is just a text. But people may understand that it will, for every floor, you know, we see the floor, and in the brackets we have every, start means that every floor. We get the every department, and we filter with the area of the apartment. So actually, this expression describes the apartment which has area in this range, 40 and less than 90 square meters. it is quite understandable. Yes, this $sign means the root of the JSON. And then we have a dot notation. I think that you know this dot notation. Question sign means that filter. And at sign means it has meaning of the current context element. So in this case, at sign means apartment. So very easy to understand. This modification is very interesting. We have a strict and lax. Lax is a strict means that if there is no key, what to do if there is no apartment, for example? Produce error or just silently skip this row. So, because JSON is a very in JSON you don't expect that all keys exist. So with this modifier, lax means that you are fine if some keys not available. You are fine. But if you specify strict, so you expect that this key should be in the JSON, and you produce error if it's not there. This is okay. This is array access, but do you remember that array in Postgres starts from zero, and you can specify like range, 0 to last. Last means the last member of array. Filtering, item methods. We have item methods which apply to the result of the JSON pass expression. And we have, it's just a function, you see this? We just a function which has a like type. Type means what SQL type has a result. Size of this JSON. We have a double, convert to double, saving, floor, absolute value, key value pairs, and date time. What's very interesting that in JSON pass we have date time support. You know, in JSON, in application, you have no date time. Date time is just a string. But in the database, we have several data types: timestamp, date time, and so on. And in database, we want to be sure that this string is actually date time. But since SQL standard doesn't describe the date time, it is not like it's not data type to store in this. It's data type to use in the evaluating JSON path expression. Yes. So you can just convert to date time, but there is no data type in the date time. To better understand what is JSON path, let's consider this simple JSON. You see, create table house like this. So you see that it has a key like address, city Moscow, and street Ulyanova and 7A. This is our post address where our company is. We have that lift. Lift is false, but actually we have elevator here, and we have floors like floor 1, floor 2. On each floor we have apartments with several apartments. So it's very simple, very native, and when you illustrate this JSON, visualize, you see these three. This root, this lift, false, address, you see, and red is arrays, and blue is objects. So we have in the leaves of this tree, we have apartments, the number, area, room number, number of rooms, and room number. So how many apartments we have? We have just 1, 2, 3, 4, 5 apartments. And then I will demonstrate how JSON path works using this structure. For example, the query I show on the slide. So we need to find some apartment with moderate area, like more bigger than 40 and less than 90 square meters. We made this JSON path expression, and green means that this is step 1. We started working with step 1. Step 1 is the root of the whole JSON here, the root. This is step 1. Step 2, we took the floors. Floors is an array, has 2 elements. Step 3, we take each floor. Then we took apartment array again. And then on step 5, we finally got the all apartments, which are objects. Then we get filter. Filter, we identify that only 2 apartments satisfy this expression. So the result of this JSON path expression will be just 2 apartments. So this is very simple to understand, you know. So you understand the power of this language. You can describe everything. This is summarized, formal description of the steps you just seen. So the first step, we got SQL JSON sequence of length 1, so JSON itself. On the second step, we got sequence of array floors. On third, we have apartments, and so on. So each apartment filtered by this filter expression, and the result is a sequence of 2 SQL JSON items. So practically, you see that we have just 2 apartments. But when you formally describe, we say that it is a sequence of 2 SQL JSON items. Each SQL JSON item is just an apartment. But SQL standard describes this language, uses formal language. Okay, so what is this? The same? No, we have the same slide with description of now 3 apartments, and we demonstrate how JSON path makes your life easy. Because with JSON path, you can just write this. Select JSON path query, and you describe the JSON path for this column from house. So very concise and has a better performance for complex queries. On SQL, before PG12, you had to write this one, SQL. So you have a sub-selects, and it's less effective than JSON path query. So JSON path not just flexible language, but also it's much more easy to write, easy to understand, and it has better performance. Better performance because everything processing inside JSON. Here in sub-select, you use 2 queries. This SQL JSON function, it's our the story of how it will be developed. So it was a developers meeting in Brussels in January 28, 2017. We discussed some developers stuff, and I was just got email about that new standard appeared. You know, standard appeared in the December 30, and we was sitting in January 28. So I got this message that we have new standard. I quickly bought this standard, opened it, and found that there is a SQL standard, accept JSON, and describe this all this stuff. And we decided with our colleague, we decided to start working on this. So this is my message with our commit. This looks like it's a historical message from any list. You see that? Me, Oleg Bartunov, February 28. I got January 28. But after the 1 month, we already sent patch implementation of SQL JSON data model with some stuff. So this our colleague, my colleague Nikita Glukhov was very fast. He was very enthusiastic to implement the standard. And for 1 month we have implementation and already sent to mailing list. When it was committed in March 22, do you see that it took 5 years. It took one month to implement and 5 years to actually commit it. So open source is not easy. It's not easy. It looks like easy, because everything is open. You can do what you want. But if you want to share your development, then it's nightmare. Because first you need to think how to write the proper English language, so other people will understand you. English is not our native language, so it takes some time, takes some energy, Then you send the patch, and everybody say, "Oh, very good, very nice." But then people start, looking inside. Yes, and some very smart guy, he could say, "Oh, this function has very bad name." Or this variable. Okay, next version of patch, you agree, you use this name, send next version of patch. Then another smart guy said, "Okay, you have extra tabs. You know tabs? Yeah. So you have extra tabs. It just looks very bad on my computer." Okay, we go to the following standard. Made change tabs, just white spaces, So it's easy. Now fixed. Then another guy said that this algorithm used not so good, not so effective, and we want to have a benchmark. Okay, we made a benchmark, we compare different algorithms, like ordering, for example, and then present to the community. But community said, we have holidays. Okay, they have holidays, the Christian holidays, Orthodox. Before, in December, but Russian Orthodox holidays, we have it in January. So actually just 1 month, just basic. Then after holidays, people start, slowly thinking, and then said, no, we need to rethink everything. Okay, we agree, and you have a talk in some big conference, and people said, that's okay, we are waiting this feature. This is very useful feature. But then again, so we have like a 50 version of patches for these 5 years. Because we also, it's not paid work. We do it for the community. So we will have other stuff to do. Yeah, that's why it took 5 years. 5 years. And then in the commit message, there was this Nikita Glukhov, who probably deserves an award for preserving. Because 5 years he was working on this, 5 years. So just open source is not difficult, not easy, but it is very good school for you. Good school to manage your time, to manage your, to be patient, to be preservant, and so on. But that's the real story of SQL JSON. SQL JSON construct function we start. It took values of SQL types to JSON data. If you mostly the behavior is the same as JSONB construction function, because before SQL JSON we had a bunch of JSONB functions. So to us it was just easy to make a SQL JSON, just wrapping around existing and correct maybe some behavior according to the standard. So what the first function, JSON. JSON, it generates JSONB from text data. It's the same like a casting. So you have text and cast to the JSONB. So now you can write just a JSON. JSON scalar also generates a scalar value from SQL data. We have a function to JSONB. JSON object. We construct JSONB object, but we have the same like JSONB build object. So it is I show this equivalent of previous function and standard function. So if you don't mind, to share your application with the other people to other database, you don't need SQL JSON because we already use this function, and SQL JSON just wrapping around. But if you want to write according to standard, to follow standard, you have to better use standard. Why standard is very good? Standard guarantee you that behavior will be the same all the years. If there is no description, not in standard, then database developers are free to change. In this year it produced one result, next year it behaves something different. That's very bad. So standard is very good, it's good thing. We follow standard, we support standard, and you are sure that your application will work with this next version of Postgres. So we have a JSON array aggregate, JSON array aggregate, which aggregates value of JSONB array. We have the same function, and JSON object aggregate. This SQL JSON construction function. Example. So JSON, it generates JSONB from text data. Syntax is very complicated. Before you just cast to JSONB, that was easy. But now, you see the expression. You describe format. You describe encoding. You say with or without unique keys, and returning what return. So it's not just casting. You could say that what to do with unique keys and which encoding to use. So this is a formal description of SQL standard. Here is an example. For example, we have JSON, two keys. Keys are not unique. And we say that we return JSON, and another is we return JSONB as JSONB. So result will be different. You understand why? Because JSON preserve non-unique keys, but JSONB replace it with the second value. Another query say that we say returning JSON, and then JSON with unique keys return JSONB. So we say that we got error because duplicated JSON object key value. So here there is no error, but here we return with new key, specifically asked. You understand this? Okay. So JSON scalar. Again, JSON scalar expression, and we say that what to return. So we have returned this scalar like a number, like a string, null and false. So you specify what different. JSON scalar from the number, from the text, from the boolean value and the false. So from null produce null and false produce false. No, this query is simple. JSON object. All JSON object has a very, very long list. You can specify everything. You can specify encoding, which format to return, what to do with nulls. For example, you see the null, if absent or null, or null. So if there is what to do if you got null, what to do with the unique keys, and what data type to return, again, UTF-8, key expression. So this syntax is like maybe too complex, but sometimes it helps you to produce, to help you to be flexible. Internally, it transports to JSONB build object call inside. And returning type, JSON by default can be JSON, JSONB, string type, byte A, or having cast from JSON. So we determine which function to use. If we use JSONB, then we call JSONB build object. For other key data type, we just return JSON build object, not JSON. Yeah. Additional keys are keys for uniqueness check with, without, and ability to omit keys with no null values. So if there is no key, what to do? We can write just null or just absent. Null or no. Here is an example. Key uniqueness checks is disabled by default. So if we say that with unique keys and there is no unique keys, we got error, duplicated, JSON key A. It's disabled by default. So by default, you got just this. What's this? Also, we can say that returning in JSON by default, by returning JSONB. Then you got JSONB. So it's a JSON object. Omitting case. So keys themselves are not allowed to be null. Yes? So if you have this JSON, select object, we get this. A, B, null, but then we say that null, absent, or null. So we just this this key value just omit. So we just have just one key. JSON object aggregate. We aggregate name value pairs as a JSONB object, and have also like good, interesting options. And their options in returning class the same as we discussed before. And the example here, we have aggregate. We want to aggregate this key with all these from generated series, and we got key 1, value 1, key 2, value 2, key 3. So we generate this JSON aggregate. Yes, and we on the second query we use the function pg type of. Pg type of returns the type of the expression. So we just check in here. So we say that we want to return JSONB, and we check. And we check if this JSONB, yes, we actually return the JSONB, just to show. JSON array, the same options we describe, but on null values not supported in subquery, in the subquery layer. I don't remember why, but internally I want to say it transformed into JSONB build array. Again, we can return JSON, JSONB, and depending on the data type to use, we use JSONB build array or JSON build array. One additional option is again what to do with the null values. And this example shows that we want to return JSON array from the string, null, row, array, some JSON-B, and JSON-B, and we want to return the JSON. And absent or null is by default. So what we get? We get string true, null just committed, yes, and all other. This is a JSON array. You see. When we specify format JSON and null on null, then we just go to null. No. So this examples very simple with the subselect. JSON array aggregates. Also, we have SQL values and aggregate to the JSON-B arrays. Syntax again familiar. You can specify encoding. Sometimes it's very important. It's all the same as a JSON array, except that we transform to the JSON-B aggregate call. Here's an example. Select JSON array aggregate from generate series, and we got an array of 3 elements. Do you know this function, generate series? Generate series, very useful function because it returns just series from the first value to the second. Now this will generate just 1, 2, 3. It's a very nice function because you can make different queries when you want to generate some data. So in this example, I generate just 3 numbers, and these numbers can go to the JSON, to this function, and we got the array. So generate series has so many applications, so I just surprised that you don't know this function. Just read the documentation. So you know that from, you understand that if this stands after the from, that means that generate series return what? Tables. Table. So it's easy, you'll just understand it. Return table, then you can write different queries to use the data generated. You can generate a return table with the 2 columns, just comma and again generate series different. Currently it has just alias I, which use here. If you have additional generate series, for example, like with alias B, then you can use this B. So we have SQL JSON retrieval function. So actually query what you write. So we have function JSON value. It is extract value, SQL JSON value from JSON data and return SQL scalar value. JSON query the same, but return JSON string, JSON query. JSON table, we query JSON text and present as a relation table, but this formal description, but practically you, with JSON table, you convert your JSON into the table, actually. So it's a relational view of your JSON data. Very, very powerful function, JSON. Is JSON, is not JSON, it's just check. If string value is valid, JSON text and what. JSON exists, you understand? But we supported only JSON-B here because people not use JSON, and we don't want, we have no resources to double our work. So we decided to do practically people with JSON-B. Here is an example for JSON value. So we select X JSON value from what all this big expression, returning integer. We want to return integer, and default -1 on empty if there is no such key. So we return -1, and default -2 if some error occurs. So we describe very nicely behavior. What's interesting that there is a JSON pass expression. This is the JSON pass expression. We're filtering for bigger value than x, but passing x as x. What does it mean? That we pass argument with this expression. We pass x to the filter argument, and this the value of this x comes from the generate series x. Very powerful. So now you know that what is generate series. It generates 0, 1, 2. So we have 3 actually rows, because one we check for greater than 0, greater than 1, greater than 2, and we got this. Let's consider for x0 we got -2. Why we got -2? Because an error default. Because there is nothing, no. Yeah. Then 2, it's just D, you know, JSON value. And for x2, we return -1 because on empty. So you'll see that JSON value is very useful function with JSON pass as the second argument. And you can pass the argument of to the filter. It's not easy the first time, but my intention is just to show that it is very powerful, very useful. Then you can read the documentation. I understand that reading documentation is not, you know, the best option. Yes, people usually mostly go to the Stack Overflow, you know. Yeah. Yeah, Stack Overflow is good, but all tools good if you apply it in right manner, you know, practically. But like 2 times per day, use Stack Overflow, not more. Else you will be just an interface to Stack Overflow. But you're a developer, you know. Developer, you can use your brains, not others. Yeah. It's like also like people use pgbench. You know pgbench. Pgbench to check the performance of your queries. So pgbench allows you to create a database. You push the queries, and on the result you get a transaction per second. Yes. It's also a very good tool just to understand how do you have some big problems with the performance. But the best benchmark is benchmark with the real data. Else you will have a pgbench optimized database. So pgbench is good for playing, but try to use not synthetic data, but real data. JSON query. Let's see. We have 1, 2, 3, 4, 5 columns. It's the same query, but with different modifiers. First is just default, then we say that without wrapper. Then we say with conditional wrapper, with unconditional array wrapper, with array wrap. And you see that n values, what we see, we test for the null, for this, no, for these 6 values. You know this function, values. Values also, with this expression, also produce table. But here it's like a single, you know, method to describe the query, to describe the data, and easy to share with somebody. They can just check. Not to create tables, insert all this data, and then select. Easy. Yeah. So this presentation will be available, so you can maybe you can find some useful techniques, you know, how to write queries. And what you see. we see that very different. For example, without wrapper, with conditional wrapper, wrapper means that we wrap the result into the array bracket. Yeah. Unconditional array wrapper, and with array wrapper, for the null is like the same. So with wrapper, unconditional array wrapper and array wrapper, they produce the same. But for this number, for the number 12.3.3, we got again this default, and without wrapper it's default, and with conditional wrapper again we say that it is wrapped. Again the same. What's the difference? Difference is unconditional wrapper. That's interesting that we got for the true the same, and for the this all these scalar values. So we wrap scalar to the array. But what to do with if we got already scalar? And that will start different. You see, a scalar wrap. Here is again. Here is a unconditionally wrapped. We have two brackets. We wrap array to wrap, and again with array wrapper. Array wrapper is we demand to wrap. So we have array on input and double array, a nested array on the output. Yes. And we have object here. So with object here, we wrap unconditional to the array and array. Okay, so you understand that? That very powerful functions provide a lot of flexibility. Why we need all these options? Because of the flexibility of JSON. Because in JSON you can get anything. Array, not array, nulls, you do not control this. But in SQL environment, you need something, to make sure. So if you expect array, better to say that unconditional wrapper, or with conditional wrapper. Then you will always have array, with conditional wrapper. Because if you have just a scalar value, conditional wrapper will just wrap to the array and you are fine. If you already got array, conditional wrapper will not wrap around. You get array. So in SQL environment you have very deterministic behavior. So that's why all this stuff, because of flexibility of JSON. Yeah. We try, SQL standard try to live with the flexibility. But in SQL we need some more deterministic behavior. SQL JSON constraints. Please read. Who understands what is here? So we create table and we create JSON, which is default for JSON query, JSON v1 this with wrapper. So this is the default value for the JSON v column. And constraint, we check if this JSON, and then we test this for all this stuff. Very it's like a whole task, to understand how it works. They check for many stuff, because again, in JSON you can get arbitrary value, arbitrary object or array. But when you put the relational database, you want to make sure that data comes are satisfied some requirements, and you describe. And these functions, SQL JSON functions, they help you to describe your constraints. JSON table, very nice. I love these functions because it creates a relational view of JSON data. Because JSON data is very good, when you work with the arbitrary data, but when you work in relational environment, you want to use a JSON data with, for example, joining with some relational table. How to join JSON with some relational table? just create a relational view of this JSON and make a standard join. So it's like a nest, which creates row for each object inside JSON array and represent value. So it's built on top of XML table. So we have already XML table committed to pitch 10, and we make use this for JSON table. Let's see example. Floors in relational form. So we have this apartment, and we want to reproduce from house. You remember, table house, 2 floors. And then we say, we want the return select apartment, so all apartment, we want to reproduce in relational, like a relational table, and we say that JSON table, JSON column, then we have some expressions that we describe which column in this, which data we want to show, yes, and we say that there is a nested path to the apartment. We describe this JSON path expression, and we have just number, area, and number of rooms. So we got standard relational table for level 1. It's a level 1 floor. We have 3 apartments, and the second floor we have 2 apartments. And for each apartment we got this JSON table. Very useful. Also, we have a JSON subscription in index syntaxes. It was very long story. It was one of the longest project. The idea comes from the very strange syntax for array. You know, when you want to update something, you have to write update command, update, set, and so on. But for array, you can just write array specific index equal new value. Very simple, you know. A brackets 2 equal 3. No problem. Why this syntax used only for array? So our Russian guy, Dmitry Dolgov, he made a generic type subscripting. We extend array syntax to other types. So we can write JSON info contacts from house. And then we got this. You see, it's just like array, but actually it's JSON. And update house set JSON info contacts to me. Alignment. Easy, then we got. This syntax already committed and you can use. But after what we, after SQL JSON was committed, we understand that it is not enough, because syntax for updating JSON values is very, currently you have to use function JSON bset, and this JSON bset has so bad syntax, so difficult to use. It's not very transparent, very difficult. So we decided to add our own SQL JSON function. We call it JSON modified. So we said that it is a missing SQL JSON functionality. Let's see the example. Motivational. For example, we want to add key big true to all apartments that have greater area, greater than 70. So what we actually want to write? We want to write like this. This is understandable, but currently it's impossible. So you have to write, you see this complex nested expression. Very difficult. So compare this and this. This is just one example why current syntax is not complete. Another example: change 2 keys, contacts and street address. So what we desire for JSON path expression, just info contacts equal new contacts, and then address street equal new. So it's easy, but currently you should use these ugly queries. So that's why we developed the JSON modify function, like very similar like a SQL standard. So JSON modify, we have JSON B expression first argument, expression operation, and returning type a Python expression. So operations could be set for update, and modificator what to do if already exists, missing or null. Operation replace, insert, append, remove, rename, keep, and some different modificator. So very simple and transparent syntax, and a lot of functionality. So we modify JSON modifier. We describe here the modificator. For example, on null, we execute when the new value is null. So if you replace by null, so what to do? So null on null, we use JSON null. Ignore on null, we just do nothing. Error on null, we raise error. Some remove on null, we remove all value if it exists. On existing, on missing, it's like the same. So you can specify. We can describe many different variants. Now we could write the first example. We add key bit true, like here. Select JSON modify, and we write this JSON pass expression and pass the argument 70 to the. This is here just for example, because we can write here just 70, but we just write more general from house. And complex query compare this query and this query. Much easier to understand. And so, but when easy to understand, that low probability to make error. And another example with the change contact and street address. Also, JSON modify, and we can use just several set operator. Easy, again. So, object case, the same. We generate this table, some table which again from generates 50 rows. We will generate series 1 to 50. Yes, and we run several queries. So we update X key to 0 and different variants, like with the JSON modified, with JSON B set, with the concatenation. You can use concatenation for JSON B and subselect. So four variants we have. Remove, rename. And we compare the performance of the different values. So here is the time, nanoseconds, milliseconds, and so on. Yes, and we compare expressions like different. The red is JSON modified, and we see that JSON modified more or less the same for set and remove, but for rename we are faster. So JSON modified not only more convenient syntax, but also it has some. It's a bit faster. So, and for we have different branch, and we go to like a 30 speed up, but we will not show it here. Yes. Again, we use an array case. This was object case. And for array case, we again run set, remove, and append. So set, we change the place, remove, we remove array member, and append, we add to the array. And again, we compare the performance. So we see that SQL aggregation is always slow. SQL aggregation, it's a concatenation. Yes. And other expressions more or less the same. So important that our function SQL JSON modifying is not slower, because it already has some value because it's very simple and transparent. But also it has good. Again, another example of complex array case. We have a different set and run different again queries, and we see that aggregation, SQL aggregation is slower, of course, and JSON modify is the fastest in all cases. Because why? Because SQL JSON function, they process JSON path with their own executor. You don't need to go several times to the Postgres executor. And we have one interesting test with the update with toaster. That means that requires some explanation that I already yesterday said about that long values actually in Postgres stores in different additional table, hidden table. And queries require some joining your original data, original table, and this hidden table. And also you have to use V3, which is a proxy structure, which helps, vacuum separate. I was very wondering why we have V3 index also hidden. And then I understand that this V3 very helpful, so you can vacuum separate parent table and toast table. And then we made a special special toast extension, which can be specific for different data types. So it has full compatibility with the old behavior by default. But if you have, for example, JSON B toaster, then we can do very magic stuff. For example, I have different presentation. I can talk hours and hours, but here just briefly describe what this JSON B toaster is doing. What if you have JSON like small keys, big keys, small keys? Do you expect that when you retrieve small keys, it's much faster than all keys? You expect, yes? You have like 1 megabyte size JSON B, and you want to get just ID. You expect that getting ID is much faster than getting the big binary, block. But that's not. Because in the current Postgres behavior, you have to detoast the whole value, reconstruct in the value in the memory, and then just get this ID. But ideally, it would be nice just to not touch the block big value, just to get this value. And this is what doing the toaster, JSON B toaster, it JSON B aware. So JSON B toaster understands the header of JSON B. And this header of JSON B describes everything about JSON B, how its size, its types, where you can find, as you know, JSON B is a binary structure. So we know how to get this key. And when we store JSON B on hard drive, we rearrange data by their size. So short values we store in the beginning of JSON B. Old values, big values, we store in the end. And JSON B toaster understand that he needs to read only block which contains this short value. and then return the result. It will not touch other. And there are maybe like a 10 optimization for JSON-B. Like 10, I have separate, separate presentation. So we, this example we made for the update with toaster queries. So we have test table and update queries using JSON-B set and JSON modify. And we use several passes, JSON-B pass, like get the key 1, get the first element of key 2, which has a key A, to several different queries, we just checking like this. What we see? So this C master, the Postgres, vanilla Postgres, and we see that when JSON-B size grows, performance becomes very bad. Well, because of the, you see, it starts from here. Because it becomes long, it stores in different tables in the toast, and we have like this exponential behavior. With toaster patched and toaster patched with JSON modify, we have queries. We see different behavior. Okay? It's like a constant performance. Increase JSON-B, but getting the keys is doesn't depend, almost doesn't depend on the size of the JSON. We have some to do for this JSON modify. Then we will present the commit to the community. Present. This is what you see. It's like a special, exceptional, for the Nepali audience. So summary, I want to say that PostgreSQL is already good NoSQL database. We tested performance with the Mongo, with the Oracle, yeah, and we are like more or less still. We're much faster than Oracle, of course, and more or less okay with Mongo. Yeah. And SQL JSON, it provides better flexibility. You have seen that queries becomes very transparent, flexible, and interoperability. So your queries will work in the Oracle, in MySQL, and other databases. Yeah, we need to modify, we need JSON modify, because this is missing analog for JSON-B set function. And this will, yeah. JSON-B is capable for great performance. I showed the example that we have a JSON-B toaster. It's very good for this. I have several topics like projective indexing, copy. Projective indexing means it's a new type of index we introduced to Postgres. You know that index, which kind of index is available right now. Just create index. Then you can create index where something, it's like that. Functionally, create index on function on something. 3 types of index. But what if you want to do index just a part of JSON and don't want to use functions? Because functions are always some overhead, and with functions sometimes it is very difficult to reproduce this in query. Let me explain. When you write create index command, create index, some functions on some functions, so you make functional index. In the query, in the select query, you have to write the same expression, the same. Else, index will not use, because Postgres understands that if he remembers the expression for the creating index, and when he see in the select, he understands that this index should work. But sometimes it is very difficult to use because your queries becomes very big, and sometimes it is impossible to reproduce the same syntax, the same expression. So with the JSON path, we can easily say that we want to create index with JSON path like this. So we don't index some garbage, which has in the JSON, and index only needed keys. And you will use JSON path expression to specify this. So this is called projection index. So we index projection of JSON data. Copy already set into format because currently you have problem how to import JSON data to the database. Like, very difficult. I tried many times, but the problem is that JSON data distributed all usually as array. You know, array and inside some JSON. But when you import to the table, Postgres table, you need arrays, you know, like rows. And you have to use like some grep set or just edit, you know, remove these brackets. With JSON path, it's very easy. You just write easy that you want to import the JSON data. And moreover, you can filter JSON data. Because, for example, for your application, you don't need, you know, the whole JSON. You need just several keys. And with JSON path, you just specify what to import. So this is also interesting to work with a copy. And this is also good for the students' work. Just add this. Unification of JSON and JSONB. This is a very tough problem, because all other databases, they use JSON. Only Postgres use JSONB. That's not good. But I said historically we got JSON as textual and JSONB as binary, and we can't, you know, change because of legacy, because of the we should support all application. But what to do if the standard will describe not just data model, but describe the data type? Then people will create a table and describe the JSON. That means the Postgres user will be a bit disappointed because JSON is much slower than JSONB. They have to change always. Change JSON to JSONB. That's not very good. So we decided to work on the unification. So you have like some variable. You say that set SQL JSON is JSON by default, or SQL JSON is JSONB as default. Then it will be like manageable. Yes. The problem is that last year we got new SQL JSON standard. SQL JSON 2022. And it describes the data type JSON. So this date already now. So this becomes very important to implement. But I said it may take years because people become, you know, discussing. Yes. Here we have references to all these talks. You can find all internals, all insights what we do in our development. Because what I talk about, this is our work. Yeah, I don't like, you know, to talk about somebody's work. Right? Yes, I talk about our work. So here you can download the whole presentation. Again, all you need is Postgres. Do you know what is this picture? No. Huh? This is the Beatles. Beatles? What's the album? What's the name of the album? Yellow Submarine. Yes, and the song, we all live in the yellow submarine. Yellow submarine. That is all you need is Postgres. Yes. So that's our slogan. Okay. Time to eat. I'm very hungry. I think that if you have any question,